Yeah, so I'm recording now, just so you know. So the introduction part of these slides I've put on the shared video. So I just want to talk about the course outline, and then very, very briefly about software packages, and then we'll dive into practicing. So if you have any questions while I'm talking, please just turn on your mic and interrupt me, okay? Just talk. You don't have to raise your hand, and you don't have to be shy about talking. I've told you a little bit about how data science is really at the mix between programming skills, statistical skills, and knowing what you're talking about, substantive skills. So in this course, we will do a little bit of a sort of bird's eye overview of different methods from data science. Some of those overlap with what you would get in other statistics or econometrics courses. Some do really not overlap. They are really more from the machine learning data science perspective. And the course is really designed, so the backgrounds of you guys varies a lot. So some of you are in economics and have done several quantitative methods courses. Others are from other social sciences and might have very little background. Some of you might have forgotten most what you had in statistics. So I'm not going to assume much technical skill already, right? So I'm assuming that you are relatively new to statistics and programming. If you're more advanced, you can go quicker. That's nice. If not, you should be able to follow the course relatively easily. Yeah. So I'm not assuming a lot of background. And the way I address that here is by, when I discuss the statistical part, the math, I will keep it at a very intuitive, superficial level. So you will not see many equations, and I'm going to talk about the intuition behind it much more than the mathematical equations or derivations. When it comes to the programming, the way that I address it, the problem of you not maybe having enough prior training, is that I really provide you with all the code you need. So when we start a lab, you can almost just click on the play button and it will run, and you should see all the output. And then the only thing I'm asking from you is to make small changes and then see what happens when you make these small changes. Yeah, so there's a lot of it is pre-programmed. And by doing this, by giving you sort of the more bird's eye overview of the statistical methods, and by having the computer code prepared, we are able to discuss quite a lot of different methods in just one short course. Yeah. So the trick of this course is to give you a bird's eye overview. It gives you an understanding of how you can use R to analyze data. You will see various different ways of looking at data and analyzing it. And the skills that you come out with, I hope, is that if you have your own data sets, you will be able to copy some of the code we used and do some analysis for yourself. Or if you end up in a job where other people are on a data science team, you should be able to really communicate with them. Yeah, you will have learned the basic language of data science and machine learning. You will have learned basic skills, and you will be able to bring in the substantive expertise that you get as a social scientist and work with, say, computer programmers, statisticians, and so forth, who might be more specialized in the other two of these bullet points. Yeah. So you learn sort of to speak to those and to understand what they're talking about. That is my purpose for this course. I can't teach you all the math that is behind machine learning, and I can't teach you all the programming that a programmer knows, but I can teach you sort of the core basic concepts that then make you able to work with those people based on your substantive expertise. But it will be very hands-on. So it's not just in theory or terminology. You will be working with data in R every week. Yeah? So by doing this, we can discuss quite a large range of different topics. And that is, I think, nice about this course. So this is a sort of crude overview of the whole course. In the first, and the course is very much divided in 3 blocks with 3 assignments, 3 data sets, and 3 ways of looking at data. Yeah, so these 3 blocks are very much key to the course structure. The first block, the first couple of weeks, we will be looking at data. We will be visualizing, making graphs, different types of plots, and see what kind of plots we can make in R and how we can look at them. And we start with quite simple plots, but then quite quickly the plots will become a little bit more complicated. And you will see that even without any other statistical modeling, no regression analysis, no deep learning or advanced techniques, you can already get a lot out of data just by you looking at visualizations. And the end result will be that we do a small group presentations. So I will provide more detail on that later. But I will put you in small groups, and you will prepare a short presentation with just I think 3 or 4 slides. And then there's one class that is just dedicated to those presentations. Yeah. Then the second block, we are going to look at models where we want to classify individuals in particular groups. So you can think of like democracies and non-democracies, and then look at all kinds of variables about different countries and try to identify which variables correspond to democracies and which correspond more to non-democracies. Or peaceful relationships and war relationships, and try to analyze data, what can predict whether some pair of countries ends up in war or does not end up in war. It's that kind of analysis that we do here. This comes closest to also what you might do if you do an econometrics course in economics. So what I keep referring to that because about a third or so of the class are economists. Then you will be doing linear logistic regression that falls in this category. But we also look at tree analysis, forest analysis, which is more for machine learning. So we look a little bit beyond this standard econometrics too. And then the third category, so in the second category, we kind of know certain categories. We know what are democracies, what are non-democracies. We know what are rich countries and poor countries, etc. And we can try to predict, or in voters, we can look at who votes and who doesn't vote. We can try to predict who votes. But we know for a certain set in the data whether these are voters or non-voters, and we can try to see how the data predicts that. The third block, we leave it more to the data to speak for itself. We are not going to say what groups we are looking at, but we're going to say how can we visualize or look at this data in more complicated ways than we do at the beginning of the course. So are there certain clusters in all the data that we can notice, or are there underlying dimensions that are visible in the data? So this is also a lot about reducing the complexity of data. You have a lot of variables and a lot of cases, and you want a more simple representation. What can we do? So there's these 3 components. There is the first is looking at data and visualizing it. The second is we have certain group classifications and we want to see which variables predict those classifications. And the third is we do not have these group classifications, but we still want to find patterns in the data. In more machine learning terms, this maps on first looking at visualization, then looking at what is called supervised learning, and then what is called unsupervised learning. So this terminology will come back throughout the course. I will make it very clear. But supervised learning means that you have a statistical model that tries to learn patterns, but the main classification is already known. Yeah? So we can have we can do a survey among voters and ask whether they voted for Biden or for Trump, and then ask a lot of other background questions. And we know which voters then said they voted for Biden, and we know which voters said they voted for Trump. And now we're going to look at what variables correlate with voting for Biden or voting for Trump. And that means it's supervised because we know already that we have 2 groups, Trump voters and Biden voters. Or in more the language of economics or politics, you would say that the dependent variable is known. Yeah, so we have a set of cases where we know the dependent variable, and we look at how the independent variables relate. In unsupervised learning, you kind of forget about this idea of a dependent variable. You just have data, and you want to know whether there are particular patterns or clusters or groups or dimensions. Yeah, so we are going to look for structure in the data without having any prior knowledge of groups or categories. And the third way in which these 3 groups differ So again, I've just changed the headings. So it's a difference in 3 different techniques, but the other difference is that we look at 3 different data sets with different types of observations. So when we look at visualization, we're going to look at survey data. We will take the Irish National Election Survey of 2020. So at the time of the elections, we held a survey in Ireland. We had something like 2,000 or so random individuals that we asked all kinds of questions about the elections. Yeah, and that is the data we're going to look to use for the visualizations. When we are going to look at the supervised learning about the linear regression and trees and forest analysis, we're going to look at more national level data sets. The observations will not be voters, the observations will be countries. And we will look at the relationship between development aid and democracy. So we have measured whether these countries are democratic or not. And we have looked at how much development aid they get. And we have some other economic data or data on population size and so forth. And we're going to look at the relationship between receiving development aid and democracy. Yeah. And in the third block, we're going to look at text data. So more and more often, especially in political science, text is used for statistical analysis. So text, of course, does not consist of numbers, but you can count the number of times each word occurs in a document. And then each observation becomes a document. And each variable becomes a term, and then you count how often it occurs. And then you get a very large data set with many more variables than for the other 2 data sets. And we can try to find if there's particular patterns. In this case, we will use State of the Union speeches in the US over the past 150 years or so, and then look at patterns in that data. Yeah. Any questions about that sort of overall structure? You're happy enough? Let's see if I can see more of your faces while I'm talking, because I see only 2 or 3. Yeah, there we go. Now I can see many more. Yeah, is that sort of a little bit clear? So the whole course is in these 3 blocks, and the assignments are then related. So you get, every week you get a lab, and then at the end of the survey data block, you will do a presentation in small groups. At the end of the national data and at the end of the text data block, you will write an assignment yourself. And in theory, especially for the national data and the text data, in theory, you can use the output from the labs for the assignment. So even if you change nothing in the lab, you will probably be able to write good assignments. Yeah. Now, I hope that you will innovate a little bit on the lab, so you will make some changes and do some of your own variations of the analysis, then see what comes out and use that maybe in the assignment, but you don't have to. Yeah. So as soon as you get the analysis to run, you should be able to do the assignment. So the assignments are really more about you being able to interpret the results and put them a little bit in relevant social science context. Yeah? So they are really more like writing essays in other courses. I'm not going to give you any homeworks where you have to do your own analysis, or homeworks where you have to calculate mathematical derivations or something. That will not be part of this course. It's always, the assignments are always about interpretation, understanding what you're reading and putting it into a context for social science. You don't really need a textbook per se. I'm not following closely any textbook, but there are 2 textbooks that are somewhat helpful if you want to look a textbook up. One is this one, R for Data Science, and it's the author, Hadley Wickham, we will see a few times. He is the author behind ggplot, which is the plotting library that we use in the first few weeks. And he's the author behind several of the most popular R tools at the moment that we also use throughout the class. And he also wrote this book. And if I'm not mistaken, I'm nearly sure this is freely online available, this book, right? So there's a website where you can find the contents of this book. I think it's linked in the syllabus, if I'm not mistaken. And if you want a little bit more understanding of the actual models behind it, then I would recommend this book. So this is quite a good, but also quite accessible textbook on most of the methods we are discussing here. And it is really written from the more data science perspective. So, for example, students who are economic students who are more used to econometrics, they will quite like this course because they will discuss the same topics that you discuss in econometrics, but in very different terminology. It's like looking from a different lens at the same thing. And that is actually quite nice. And I think this is quite a good book, quite a good reference. So this is worth your. It's not so expensive, I think, but it's worth your investment. It is actually a simplified version of a more technical textbook. So if you want to go really deep, there is also a book called The Elements of Statistical Learning, and it's a book by more or less the same authors. It's much thicker and much more mathematical. But if you're really very enthusiastic at the end of this course and you want to delve very deep, then I would highly recommend The Elements of Statistical Learning. But as a sort of more introductory overview, then this is an excellent book. And one thing I like is that these authors are they are big names in the field and they are very precise in their formulation. So I personally have quite a strong dislike of statistical textbooks that are not very precise and accurate. These authors, they are they write very accessibly, but they are correct in how they write. Yeah, so there's these 3 assignments, as I already said. First, the presentation, and then 2 assignments. They are always based on the lab. You can, but you don't have to add new analysis to it. But it's more important that you are able to understand what's going on in these labs and be able to interpret them. Yeah, so I think the syllabus has a bit of a discussion of what the structure for these assignments should be. Like roughly what percentage of text should go in each section. So that's good to look up when you work on the assignment. Yeah, so you should find a little bit of relevant academic literature, then take the output from the labs and write an essay that incorporates this output and connects it to literature. I'm never really sure what to say about plagiarism. I want to raise it every time, but the bottom line is just don't. Yeah. So if you write an essay, please do not use online material without proper citation or quotation, or your own essays from other courses without proper citation. If you have any questions or are you unclear about how to cite something, you can always ask me. And there's also guides in the library that can help you. Some of you, you try online websites where you can check against plagiarism to see if your own paper is plagiarized. So first of all, if you have to check, there's probably something already wrong. Yeah, so you should worry about what you're doing when you're checking. But also, these tools do not detect as well as the plagiarism software we use. Yeah, so it's also not going to help you. If you need me, you can just drop me an email. Oh, sorry, I forgot to change this. It's of course spring 2021. Yeah? I'm sorry about that. That's the course website last year, which is of course quite similar, but anyway. So I don't really use Brightspace. I don't upload much in Brightspace. So please use this course website and everything will be there. And the Zoom link, if I'm not mistaken, is fixed. So you will have the same Zoom link every class. Yeah. Any questions about the course outline? None? You're all very happy? All clear? Nobody panicking yet? Wait till you start using R, then the panic comes. Okay. A little bit about software packages. So the rest of the slides is very there's very few slides, so I won't be talking long. This course uses R. So here's a little bit of the popularity over time for different software packages. So It used to be that SPSS was very popular for, especially in social science. So the top line is the popularity of SPSS over time. And so as you can see, it was very, very popular until about 2008 or something. And then it just collapsed. Yeah, it's sort of disappearing from the discipline. And SAS is the other very popular statistical package, used not so much in social sciences, more in pharmacy and medicine. SAS has the advantage it can use much larger data sets than SPSS can, so it's primarily used in disciplines where the data sets are huge. But also SAS is completely declining in popularity. Now the bottom lines you can't read, so for that we need to change to a log scale. This is the same graph, but you can. What changed is the axis on the left. Yeah, so here on the left it goes in jumps of 50,000 at a time. Here it gets 10 times bigger every time. Yeah, so 10 to the third, 10 to the fourth is 10 times bigger than 10 to the third. 10 to the fifth is 10 times bigger than 10 to the fourth. So we changed the scales to make the plot more readable. Yeah, so now you can see these lines there at the bottom a little bit. And you can see that R is the most popular new alternative to SPSS and SAS, very closely followed by Stata, which you will probably be using in economics. And then there are some other packages that are a little bit less popular, but still present. Now, so we are using R in this course, and it is really the upcoming system. Now, I should add, this is a software comparison using statistics. I should say that in data science, there is another language that is very popular. So in data science, the main competition really is between R and Python. Yeah, so Python you will see a lot too, and R you will see a lot too. And currently among professional data scientists, it's about 50-50, I think, between using Python and using R. So both are very popular, both have similar tools implemented. But R is also used a lot in political science, economics, and so forth, and statistics, and Python really not. Python is more among programmers, so people that come at data science from the computer science perspective. So R will give you more skills that are very common among data scientists, but that are also useful in the more social science disciplines. Yeah, so R seems to be the most appropriate language to learn here. One thing that is crucially important in general, I think, in social science, so for something to be scientific, replicability is very, very important. Yeah, so when you do an analysis and you come with certain results, and people later approach you and ask, so what exactly did you do and how did you exactly find these results? You should be able to answer that question. Yeah, and that is often harder than you think. So if you press a few buttons in SPSS or in Excel to get some graph, and later somebody asks you, what exactly did you do? It's often hard to remember which buttons exactly you pressed in what order to remember what you did, right? Or I remember many years ago to have to do some analysis for a professor. He had some paper published and he wanted the tables repeated. And he just gave me a log file which contains every single command he ever tried in the development of this paper, including everything that failed. Yeah? So he had only one table in the paper, but he had 100 different commands in Stata that would create tables. And apparently he selected one of them, but none of those 100 produced the table that he had in the paper. Yeah? And then it was up to me to figure out what he had done. That is not how you want to do social science. Yeah. So you need to have a clear overview, a clear set of commands that when anybody takes those commands of you and runs it on the same data, they get the same results that you have. And that is very important. So whichever statistical software one uses, SPSS, Stata, R, Python, you always need to have some kind of script file that contains all the commands and that produces the output you have. We will be using R, and we use RMarkdown to create this kind of script. So R has some advantages and disadvantages. So big advantages, of course, just the popularity, and I want you to learn to communicate with data scientists, and they often use this. So this is part of the point. It has some other pros. It's free software, so you can download it on your own computer and use it without any problems. The library, so many people add new features to R all the time, and they are uploaded on the net, and you can download them and use them. So that's a big advantage. It is a real programming language. So unlike Stata, Stata can be programmed, but the language behind it is very awkward and unusual. R is a bit closer to how normal programming languages are designed. And this means that it's a bit more flexible. You can do more. A big advantage is that the user base is very large and very active. And most importantly, this means that when you go to Google and you search for a question, when you're stuck with R, you will find answers immediately. Yeah? So using R, I think, is about 40% of the time using Google and type what you want to do and find the answer. Usually on a website called Stack Overflow, you will see that a lot. But in general, there is just a very large and active user base. So this also means a lot of presence online, and it means that you get great answers to all your questions. One thing that R can easily do is open multiple data sets at once, which Stata, for example, cannot. And the graphics, the visualizations tend to just look better than in most other packages. So the graphic visualization is kind of is neat. It looks good. Downsides of R is that because it's free and because so many people contribute packages, they can often be inconsistent, which means that the quality of the documentation varies a lot between different packages. Some are very well documented, some are very poorly documented. Unlike, for example, Stata, which has amazing documentation. And it also means that the way you call a function varies between different people that implement it. So one wants to have the dependent variable first and the independent variable second, and then you have another package and they want the independent variables first and the dependent, this kind of silly inconsistencies. And that is just because different people wrote these different packages. And the one downside is that the learning curve at the beginning with R is steep, steeper than other statistical packages. Yeah. So you will struggle a bit in the beginning, but for that reason, I'm providing you with all the codes. I'm helping you here, but don't get panicky in the first 1 or 2 weeks. It will be a bit of a struggle before you get used to it, and then you will be you'll be fine. And there's no graphical user interface, but for that we have the next slide. So on your computer, you should definitely install R, and you install R first, and then secondly you install RStudio. So RStudio is a separate program. In the background, it will call R, but that's it's separate. But it has this kind of visualizations. You get a screen that looks like this, where on the top left you can write the code that you want to use. On the bottom left, you can see the output of that code. On the top right, you can see all the different variables and data sets that you have open at that time. In the bottom right, you will see any figures, visualizations you create. So everything is together in one screen, and it makes it much easier to manage. So we will be using all the time in RStudio. And it's very important that you install R and then install RStudio and have this ready on the computer that you use to log into Zoom. Yeah, so this is what we will be using every week, including today. Yeah, so I think I already said what is where. Yeah, we will get familiar with this in a bit. The one other feature that we use, so we use R, and then on top of that RStudio, and then in RStudio we use RMarkdown. RMarkdown is a particular formatting language, description language, that that integrates both text and R code. So what you can do here is you can type text that discusses what you want to analyze, then you insert the code, the R code that does the analysis, and then you can also add text that interprets it, for example. So you have everything together in one document, makes it easier to manage. And you can, for example, write your entire essay in RMarkdown, and then you press compile and everything comes out at once. The analysis, the interpretation, the code that you use to generate this analysis and so forth, everything in one document. It makes it very easy to manage, and it's concise. And also all the labs, they are produced in RMarkdown. So RMarkdown always has, let me see if I can write on the screen. So this is a typical format for an RMarkdown file. So it starts with a header that has just the name of the title, the author, the date, yeah, and it states that you will have an HTML document coming out. We will always use HTML probably. So this stays more or less the same. So you can imagine that you put lab 1 here, you put your name here, you put the date of the lab here. You leave this the same, and then that is the file that you use. Yeah. And then there are certain symbols. So these hash symbols here, they mean that we when we compile it, this becomes a title, a big font, black written text. So you can put one hash and then the title of your first block, whatever text you want. And this makes it a slightly smaller title. And you can add any other text here in the document. Any text that you write here or here or here will become part of the document just as plain text. So you can write it as an essay, you can write paragraphs, titles, etc. what you want. And then important is this. So this line here and this line here, they are very important. They are very awkward, and you will be encountering them every week. So you better get yourself very familiar with them. So there's these 3 backwards quotes, these 3 ticks to the left. Then a curly bracket, then an R to indicate that R code will follow, and another curly bracket. And this block ends with again 3 of those ticks. So this block, the block that starts with these 3 ticks and R and ends with these 3 ticks, that contains R code. And the computer will interpret this as code. And when I click on knit, this is knit here. If I click on knit, it will produce a web page and an HTML document, which this turns into a title. All the normal text turns into text. And here it will actually run the R code and produce the output and put that in the same web page. Yeah. And you can have different blocks of those. Here's the second block. So the lab is going to look exactly like this. If you, I will show you in a minute, but if you look at the lab sheet, it will be an RMarkdown file like this. And you will be able to either insert code in these R blocks or to add new R blocks at the end using the same 3 ticks and R and add new code. And that is really how you should be doing your lab. Yeah. So this slide is quite important. There's also a separate video on using RMarkdown with a sort of a demonstration. And you definitely, after class today as well, want to probably rewatch that and make sure you're very familiar. Because in my experience, so I've been teaching this course a couple of years now. In my experience, it's not so much the statistics that is most where students struggle most. It's this block where students struggle most. So people confuse themselves. They put R code in the main text, or they put the main text in the R code block, or they forget the 3 ticks, and then you get all kinds of error messages. So it's really important, and really, if you get this system, this structure correctly in your, then you make your life in this course a lot easier. Yeah. Are there any questions about? I will give a demonstration in a second. But any questions about this slide in particular? No, you're all happy. Don't worry, the questions will come. Okay, that is. We'll talk about that more later. So we will typically be looking at data sets. So a data set where every row is an observation and every column is a variable. So for example, this would be a survey where 8 different individuals were asked what their age is, whether they voted or not, what party they voted for, their level of education. You can't see what's on the right. Oh yeah, the gender. So this means we have 5 variables in this data set, 8 observations, and we can do analysis on this. So that's just the structure. You will be able to see that in R. Now this can be saved in many different ways. So perhaps somebody else used Stata or SPSS and saved their data, and now you have access to it. Maybe somebody made a table somewhere on a website. Maybe somebody used Excel to collect all this data. maybe they're plain text files and so forth. Most of those in R can be opened with just one command, which is the import command. The import command can open Stata and SPSS files. It can open Excel files. It's a very, very helpful command. So it makes our life a lot easier. So there are many packages in R. We will learn about packages in the rest of this class, I think. Rio is one of those packages that you can open and use. And then in that package, there is the import command, and we can access a data set. So we will see that a lot. In fact, I can give a quick example. Can I type here? Yeah. So in our code, this would be library Rio, which means opening the Rio library. And then we can access a data set. For example, I might want to call it D for data set or DS. And then import, and then I have some kind of file names. Yeah, this is an example how you would open an Excel file in R. So this means accessing the Rio library, which has the import command. This means to import a particular Excel file that is on your hard drive. This means to assign it to a particular variable in your workspace. And this is the name that we then give to that workspace. So this structure you will see all the time. Yeah? And you will see it in the lab or immediately in the first lab. So you don't have to memorize it, but it's just that to give you an idea. Okay, so this is demonstrating. This is what I should be demonstrating. Okay. So let me first actually quickly show go to the website steps here. Just quickly. So this is the course website. You have seen the course website, I hope. Yeah. So here's the syllabus that you should. I should be able to draw again. Huh? So here's the syllabus. The yellow doesn't work. Syllabus that you should download and closely read. It has instructions for the assignments, overview of the course, and so forth. But typically, so every week you will have the same kind of layout. I will have lecture videos, one or more, that contains a short lecture. I think the lectures will typically not be more than 20 or 30 minutes. They will not be particularly long, where I just introduce the main model we're going to use. And then I often have some additional little videos just for small things around R that might be helpful. Yeah. Or I might have some additional videos. And you can see, of course, that in March we got COVID, so there is where I started recording lectures. So these are lectures from last year, but I'm not going to re-record them all. So, but the lectures here will be populated a week or so in advance every time. More importantly, you then have always these three links here. Yeah. So the first is the slides that I use for the lecture and that you can use as a reference. But more importantly, here's the RMarkdown file with the lab. And here is the output. If you run the RMarkdown file in RStudio, what you should get. Yeah. So let me open those two. Can I do that this way? Yeah. So the RMarkdown file, if I click on lab, so now I just clicked on lab and opened it in the browser. This is not useful for you to do. What you will do, you will always right click on it, or on a Mac control click on it. And then, where is it? Save linked content as. That is the, if you use the Opera browser. I think in other browsers it will be called slightly different, like save link as or save. It varies a little bit what it's called. But the key thing is, if you just click on it, it's not going to help you. You need to right click on it, or on a Mac control click on it, and then save the file to your hard drive. Yeah. Now that lab file will look something like this. Oh, let me remove the drawings. It will look something like this. So this is an RMarkdown file. Yeah. So we again have this intro block, which has the title and the author and the date and so forth. And then we have examples of our code. This is our code and this is our code. And we have titles and we have just text. Yeah. So this is an example of how these two are integrated. And when I go down a little, so in the very first lab, but I think that's only in the first week, you will sometimes see this eval is false. That means that RMarkdown is going to ignore that block. It's not going to run it. But this is a typical normal block. Yeah. So that is an R command that will be run, and this is how you have a block. And you will quite often see this in R. The hashes means comments, so they will be ignored, and you can just delete this line when you have downloaded the lab in R and opened it in RStudio, and replace it with whatever code you need to answer the question that is being asked. But it's easier if you practice. So I think I just want you to, I will put you in a small group soon, and then you can practice with that after the break. So this is the RMarkdown file. So this one you download by right-clicking, saving to your hard disk, then open RStudio and open this file. Yeah. So this is the file. This first file, the lab, is the one that you want to open in RStudio. The second file, output, which looks like this, you don't need to open, but it's just helpful for you as a reference. Yeah. So if I open this file in RMarkdown and I click on knit, yeah, remember that word you want to remember. Yeah, if I open this file in RStudio and I click on knit, the output is this file. Yeah, the result is this file. Oops. How do I get there? So that will look like this. So you will see that the titles have now become real titles. It's the text and the R code that is there. For example, this is the example that I gave you of the R code. So this is the code that has then been run. And sometimes it will have output. For example, here, names INES is an R command, and this is the output. So this was not in the text document that we just saw. Yeah. So I might, let me show you in RStudio actually. Give me 1 second. Stop sharing. So this is what RStudio looks like. So this is what you'll be looking at a lot over the next weeks. So I can open a file. I'm actually not sure. Can you see me opening a file? Maybe not, huh? I don't know what you see there exactly. But either way, so when you open the file, it will look something like this. This is the first lab, lab 1. This is the RMarkdown file. This is the file that I downloaded by right-clicking on lab on the website and then saving it. And I can look at it here. Then if I click knit here at the top, it will compile the document. It will go through all these steps that you can see at the bottom. It can take a little bit of time, and as the course progresses, it will take longer. And then on the right, you see the output. This is the output that is generated from this input. Yeah? And there you can see all the different, this text here, it says, statistics helps us to analyze data. So that just becomes text here. Statistics helps us to analyze data, right? And the commands, for example, there's a good example. Yeah, here it says table INES party. And then if you go here, we have this same command, table INES party, but it also produces then the table. You can see that there are 300 respondents who said they voted Fine Gael, and 360 that voted Fine Gael, 250 that voted Greens, and so forth. Yeah. So this command here, which then does not have any output here, of course, on the screen, when it's compiled, when you put init, it will give you the output here. So it is really important that you start to become familiar with this process. So what I suggest is we now have a 10-minute break. And then when we come back, I will put you immediately in small groups. You all try to make sure you have RStudio installed. Can I do a quick quiz actually? I'm gonna stop recording.